This video is for section 5.4. This is AP Calc BC. So using first derivative tests to determine relative, which means local, extrema. So some of this, let me zoom in a little here. Some of this we have looked at before, the plural form of extreme, that is all the maximum minimum values are maxima and minima. So first derivative test. So this says C is a critical point. So you've already found your critical points where the derivative equals 0 or the derivative is undefined. On the open interval, F is differentiable, which implies that it's continuous, except possibly at C. Then F of C can be classified as follows. If the derivative changes from negative to positive. So I'm going to go to these pictures here. So this would go with situation 1 up here. If the derivative changes, so this is the function, and if this is the function and I put a tangent line here, the tangent line would have a negative slope, so the derivative is negative. Here, f prime equals 0, and you end up having a minimum. Here, f prime is positive. So remember, greater than 0 is positive, less than 0 is negative. If I put a tangent line over here, the slope of the tangent line is positive. So if the derivative changes from negative to positive, then that point is a minimum. If the derivative changes from positive, this is positive, to negative. So if you were sketching a positive derivative, means function is increasing, then it's 0, then it's decreasing. That would be a maximum. So that is what situation 2 up here is describing. So this goes with 1, this goes with 2. The other one says it does not change signs. So this could happen. Your function is increasing and then it flattens out. So your derivative is 0 here. You would have a horizontal tangent. And then it keeps increasing. So if you draw your tangent lines, they both have a positive slope. So then you don't have a max or min. Same thing could happen the other way. Decreasing, 0, decreasing. When I say 0, I mean derivative is 0. Slope of the tangent line here is negative. Slope of the tangent line here is negative. So this would be neither a max or min. All right, so let's use the first derivative test to do some problems. So it says find all the points that are relative extrema of this function on the interval 0 to 2 pi. So let's start with finding the derivative. So f prime of x would be 1/2 minus cosine of x. Cosine is always a constant function, right? You know what cosine function looks like that. If you're adding a number to the end, it's just shifted. That's a really bad cosine function I just sketched there. There we go. It's just shifted, but it is continuous, and it's going to be, this will be differentiable everywhere. Differentiable, I'm going to say for all real numbers. So I don't need to check where is the derivative undefined to find my critical points. I just need to check my only critical points will be when f prime of x equals 0. So I want to solve this equation. 0 equals 1/2 minus cosine of x. So 1/2 equals cosine of x. And remember your unit circle. So where is cosine 1/2? So this is, cosine is square root of 3 over 2. So it's going to be right here and right here. And I'm only doing once around the unit circle. Over here, cosine is negative because your coordinate points are negative, positive. And over here, cosine is negative. So It's positive 1/2 at pi over 3 and 5 pi over 3. So x equals pi over 3 and 5 pi over 3. So that's where the derivative is 0. Now I have to figure out, is it a max or a min? So I'm just going to do my little sign chart here. And my critical points are pi over 3 and 5 pi over 3. Okay, now I'm checking derivative here. So I'm just going to remind myself I'm checking the derivative. I know the derivative is 0 here and 0 here. So now I just need to figure out, is the derivative positive, negative, or positive? So if you pick a point over here to the left of pi over 3, so well, you could really put in anything. I might put in a unit circle value. Plug it into your derivative. You're going to find that the derivative is negative there. And then in between here, derivative is positive, and here is negative. So I'm not going to go through all of these, but for instance, if you check f prime of pi over 6, so that would be here. So that would be to the left or smaller than pi over 3. You would have 1/2 minus cosine of pi over 6. And that would be 1/2 minus square root of 3 over 2. Now you don't actually have to do this whole equation here. You just have to think, will this answer be positive or negative? Well, square root of 3 is going to be bigger than 1. It's going to be somewhere between the square root of 1 and the square root of 4. So that would be between 1 and 3. So it's going to be bigger. So this answer is going to be negative. So I just need to know whether it's going to be positive or negative. So then you could do pi over 2 for this range. So check f pi of pi over 2. And then bigger than 5 pi over 3, you could check like 11 pi over 6. So you want to check in those three regions and figure out the sign of your derivative. Now what I do here is I sketch the function. So if derivative is negative, function is decreasing. And then horizontal tangent, derivative is 0 here. So I have a horizontal tangent. And then I increase derivative 0 again. So that would be a flat spot or a horizontal tangent, and then decreasing. So I sketch, what I just sketched is f, not f prime. And then it kind of shows me this is going to be a min and this is going to be a max. So I know I have a min at x equals pi over 3 and a max at x equals 5 pi over 3. Now, up here in the directions, it said find the points. When it says find the points, you need to find x and y. So before I put my answer here, I'm going to do my answer over here. So this is kind of my work. I need to find the y value. I already know I'm checking x equals pi over 3. That's my min. I wrote pi over 2 here. It should have been pi over 3. And my max at x equals 5 pi over 3. So I need to find the y value that goes with that. To find the y value, I'm plugging into my original function, 1/2 x minus sine of x. So this is going to be 1/2 times x, which is pi over 3, minus sine of pi over 3. So this is going to be pi over 6 minus sine of pi over 3 is square root of 3 over 2. Keep writing 2s when I should be writing 3s. So that is my y value. So this coordinate point is over, x is pi over 3, y is pi over 6 minus square root of 3 over 2. All right, now then you need to find f of 5 pi over 3. I'm going to let you pause the video and do that. Pause the video, and magically you should have gotten 5 pi over 6 plus square root of 3 over 2. So I now have my coordinate points. Remember, this one is my min, and this one is my max. 5 pi over 3, comma, 5 pi over 6 plus square root of 3 over 2. Okay, so f of x has a relative min at the coordinate point pi over 3, comma 5 pi over 6 minus square root of 3 over 2, because f prime of x changes from negative to positive. This is your justification. This is how you would justify on an FRQ also. F of x, and remember, you're talking about where the original function has a max or min, so make sure you say f of x has a relative max at the coordinate point 5 pi over 3, comma 5 pi over 6 plus square root of 3 over 2, because, or where, either one would be fine, f prime changes, so think up here, changes from positive to negative. If I can fit this in. Now, a couple of things for documentation. Never say the function, because if you think about this problem, we have talked about two functions, f of x and f prime of x. Never say it. I don't know what it is. So be very specific. This is f prime. F prime changes. This is f of x, has a max or min. Never use the words it or the function. Be very specific. Find the points of relative extrema when f of x equals this. Okay, we'll do this one. I need to start by finding f prime. So f prime of x, this is chain rule. Derivative of the outside would be 2/3 times the inside unchanged. And then I would minus 1 from 2/3, so that would be negative 1/3, times derivative of the inside, which would be 2x. And then if you do a little simplifying on that, I'm going to have on the top 2x times 2, which would be 4x. This is a negative exponent, so I'm going to move that to the bottom. The 3 is going to go on the bottom because it's the bottom of my fraction here. And this is the third root of x squared minus 4. So that's f prime. So remember, critical points are where derivative is 0 or derivative is undefined. This will be undefined. So f prime of x is undefined when the denominator is 0, right? When x squared minus 4 is 0, because we can't have 0 in the denominator, or when x equals plus or minus 2. So those are critical points. Now, I also need to check where is f prime equal to 0. So remember, for a fraction to be 0, I just need to set the numerator equal to 0. So my other critical point is x equals 0. So those are my critical points. So I want to do my sign chart with -2, 0, +2. And then remember, I'm checking the sign of f of x. No, sorry, f prime of x, derivative. So you would have some work here. If I pick a number over here to the left, I would, for example, find what the derivative is at -3. So if I put -3 into here, I have -12 over 3 times the third root Negative 3 squared would be 9. 9 minus 4 would be 5. So that would be the square root of 5, which means I'm going to have a negative answer. So this would be a negative. Here I would check negative 1. So then you would do f prime of negative 1. And I'm going to tell you, you would get a positive number, but you should practice doing that. So this you get a positive, this you get a negative, this you get a positive. So they do change signs at each of these points. So now let's sketch f. So derivative is 0 here, here, and here, which means I'm going to have a horizontal tangent or a flat spot or a max or a min at negative 2, 0, and positive 2. Derivative is 0, function is decreasing, and then 0, and then it increases all the way to here, and then it decreases, and then it increases. So this looks like a min, this is a max, and this is a min. So find all points that are relative extrema. So I need the y values that go with them. So I need to find f of negative 2, which is 0. I need to find f of 0, which is the third root of negative 4 squared. Actually, I would do it like this. Negative 4 squared, third root, which would be third root of 16, which I can't do anything else with, so that's f of 0. And then f of negative 2, f of positive 2 is 0. Okay, so f of x, not f prime, the function f of x has relative min at the coordinate point negative 2, 0, and 2, 0 when f prime of x changes from negative to positive. Okay, and then f of x has relative max. I spelled relative wrong up here, R-E-L-A. Relative max at the coordinate point 0, third root of 16, when or because f prime changes from positive to negative. Okay, I think there's just one more. Yeah, I think I'm going to say you try this one. And then the bottom of these notes have the actual graph of the 3 examples that we just did. So this is the one we just did where it was undefined at those 2 places. The derivative was undefined because you have a corner. So I want you to try this one. I'm going to tell you, you should get a min, and it would be a relative min at negative 1, 2, and 1, 2. And that is it. So you should not get there is no relative max. Oh, I can't spell relative. Okay, so try that one again. If you need help with it, there's a video there.